Hi, in this video, we will talk about vector, okay? So to understand the vector, you have to understand the vector has the direction and the length, okay? To understand this one, you have to understand about the initial point, which is starting point, and terminal point, which is end point, okay? So let me give you the general idea about the vector, okay? So, let's say this is initial point. Like, let's give the name A, which is x1, y1 as the component notation, okay? And then your vector is moving from there to here, which is terminal point. And I can say it is end point. Let's say this B as a component form, x2, y2. Then to write this one as a vector, you have to use the right triangle, okay? Then, okay, this base length is the change of x component, which is x2, terminal point minus x1. So this length is x2 minus x1. And then what about this guy? The change in y, which is y2 minus y1, okay? So like x2 minus x1, which is length of base, is your x component of your vector. And the change of y is your y component of vector. It's really similar with like slope formula, right? Slope formula was rise over 1, which is delta y over delta x, okay? This y2 minus y1 is exactly delta y, and x2 minus x1 is delta x, okay? So from this one, I can say the vector AB is equal to vector bracket x2 minus x1, comma, y2 minus y1. Is it okay? So let me apply this one to this problem, okay? Look at that. A is the initial point, which is given by negative 3, 4, and B is the terminal point, okay? Then your vector, AB is equal to terminal point minus initial point in x component, and terminal point minus initial point for y component. That is equal to 4, negative 6. This is the way to write your vector with initial point and terminal point. Okay, let me give you a couple more examples, okay? So here we go. The problem B, the initial point is 0, 0, and your terminal point is 1, 1. Before writing this as a vector notation, but let me show you the graph first, okay? So, okay, x and y coordinate system. Like the origin point is your A, and your terminal point is 1, 1, right? 1, and x is 1 and y is 1. This point is your terminal point B. And then this is your vector. Is it okay? It's visual, okay? So now writing as a vector is really easy, right? Vector AB is your x component is x2 minus x1, which is terminal point minus initial point in x component, and terminal point minus initial point in y component as well. So your vector is 1, 1. That's it. This is easy, right? What about second one? Like second one, like your initial point is negative 2, 2, and your terminal point is negative 1, 3. Okay, let me give you the graph of this one too. Here we go. Negative 2, comma 2. This point is your A. Okay, and negative 1, 3 is here. It's too far, but maybe somewhere here. Let's say it's B, negative 1, 3. Then this is your vector AB, okay? Then in a vector bracket notation, we can write this one. Again, terminal point minus initial point, comma, y component, terminal point, initial point, which is equal to 1, 1. Okay? So, well, like in this problem, I would like to talk about one more thing. Okay? So look at that. like, you know, problem B answer is 1, 1, and the answer for problem C is also 1, 1, okay? They are same notation, okay? But are they same? My answer is yes, okay? They are same vector, okay? Let me give you like general idea about the vector, okay? As long as they have same direction and same length, then they are all same vector. Is it okay? So if I say this vector as A, then this is also A, okay? So what about the other one? If I have another vector here with the same length and same direction, is that a vector A as well? Yes, it is vector A. Even it is here, doesn't matter. It is still vector A. All those are same vector, okay? But the problem B, that vector has the special name because it starts from the origin, okay? So we're going to say this vector is the position vector. But technically, they are all same vector, okay? This concept is really important for the future study, okay? For your engineering study as well, okay?